So now that we know how to write and balance chemical equations, we're going to take a look at the types of reactions that we're going to encounter. In general, there are 5 types of chemical reaction that you need to be aware of. The first is called synthesis, decomposition, single displacement, double displacement, and combustion. These are the 5 types that we're going to learn. Why 5 types? Well, the interesting thing is that each type of reaction has different characteristics. So they're all unlike the others. They have different types of reactants. So the things that we're reacting together, depending on what they are, they will react differently. And they have different types of products that will be produced. There are rules that we're going to learn for each of the types that will allow you to take some reactants and predict what's going to happen. And that's our goal for the next few lectures, is to be able to identify, based on the reactants, what type of reaction is it, and then what is likely to form. Once we do that, we can write a balanced chemical equation for the reaction as a whole. Okay? So we're going to start by looking at synthesis reactions. The word synthesis means to make something. The general form of a synthesis reaction is 2 things, A and B, combine together to make one product, AB. Now the reactants that we'll encounter are either going to be a metal and a nonmetal, or 2 nonmetals. That's it. So anytime you're looking at a chemical reaction on the reactant side, on the left side, you see a metal and a nonmetal elements, or 2 nonmetals, it has to be a synthesis reaction. Okay? We only form one product. That's the key when looking at an equation. One thing on the right, one substance formula on the right. Okay? If the 2 reactants are a metal and a nonmetal, then that product will be an ionic compound. If the 2 reactants are 2 nonmetals, then the product will be a molecular compound. So it's pretty simple, actually. Okay? You have to be careful, though, of the transition metals. So if you have one of your reactants is a transition metal, specifically lead or tin or iron or copper, because those guys can form more than one possible positive charge, you have to be careful when writing your product. Okay? The good thing is to just pick one of them. All right? If you want to be specific, you can pick the one that's in bold on your periodic table. We talked about how to do that well earlier in the year. But in general, pick one, either one, and make that the one in your product. Okay? If it's a molecular compound that you're trying to make, just pick one you know. And we'll see some examples of this so you can get an idea of how it works. Okay? So here are some examples. I want you to stop the video and jot these down and leave some space under each one so that you can write an equation so we can talk about it. Okay? The first one is lithium metal is added to nitrogen gas. Notice I don't tell you what's being produced because we're going to predict it based on the rules. The second is powdered iron reacts with powdered sulfur. And the third is sulfur reacts with oxygen in the air. So write those down in your notebook, leave some space under each one so that we can write a balanced chemical equation. All set? All right, so let's take a look at the first one. Lithium metal reacts with nitrogen gas. So lithium is simply Li. Now it's a metal, and metals are going to be solid at room temperature, so don't forget we have our state symbol. Nitrogen gas is one of the 7 diatomic elements. Nitrogen is never just N by itself. It's always N2, and that's a gas. Okay? So those are my reactants. Now I have to predict what's going to happen when these 2 react together. This is a metal. This is a nonmetal. So according to my rules, when a metal and a nonmetal react together, they combine to form an ionic compound. The ionic compound is going to be made of lithium and nitrogen. Now we have to go back to when we first learned about ionic compounds. Lithium forms a +1 ion. Nitrogen, when it forms the nitride ion, forms a -3 ion. None of this should be new, by the way. We crisscross and we get Li3N. Okay? Li3N. Now, ionic compounds, if there's no water involved, this is really important, make sure you write this down. If there's no water involved in my equation, then an ionic compound will always be a solid, because ionic compounds are solids at room temperatures. Now, I need to be able to balance this. So I look and I say, okay, I've got 1 lithium here and I've got 3 here. I've got 2 nitrogens and 1 nitrogen over here. Okay. Well, let's try getting the nitrogen the same. So I'm going to put a 2 in front of the Li3N. That gives me my 2 nitrogens. There they are on this side. But that also gives me now 6 lithium. So I need a 6 in front of the Li. So this is my balanced chemical equation for the reaction of lithium with nitrogen gas. So the next one that we want to do is powdered iron reacting with powdered sulfur. So iron is a metal. It's a powder. So we put a solid there. Sulfur is also a powder. We do that. Now we have a couple possibilities here because iron, you remember, can form both a +2 and a +3 ion. Because I have 2 different possibilities here, that means I can make 2 different compounds. You can just choose one. You may choose to use the iron with the +2 charge. That would be Fe +2 and S -2 FeS. This is an ionic compound, so it's also a solid. And it happens to be balanced as is. However, you might also decide that you want to use the iron with the +3 charge. Fe with +3, S with -2 would be Fe2S3, also an ionic compound, also solid at room temperature. This one's not balanced. I have to actually balance it, so I'm going to need a 2 there and a 3 there to get that balanced. Either of these is correct, although technically this one is a little bit more correct because iron prefers to be the +3 charge, and so this one was more likely to form. Our final example was sulfur reacting with the oxygen in the air. So sulfur, that's a solid. Oxygen is one of those diatomics we talked about, O2, and it's a gas. Now, we talked about at least 2 compounds that contain sulfur and oxygen. One was SO2, that is a gas, and this happens to already be balanced. The other was SO3, which is also a gas. This one's not balanced. I've got 2 oxygens and 3 oxygens. Least common multiple, 2 to 3, is 6. I have to put a 2 there to get my 6 oxygens. I have to put a 3 here to get my 6 oxygens. And now I need 2 sulfurs over here as well. So this is the other possible equation, and neither one is more correct than the other. They're both perfectly fine and perfectly acceptable. So when you have 2 nonmetals like sulfur and oxygen, make sure that you choose a compound that you've heard of, that you have in your notes someplace, and just use that. Decomposition reactions are sort of the exact opposite of synthesis reactions. We start with one substance, and it decomposes into more than one. It breaks down. Okay? Now, the ones that we're going to be interested in are binary compounds, means that they're made of 2 elements, decomposing into their elements. Okay? Watch out for diatomic elements. Be careful. Make sure you know all 7 of them. Here are some examples. Go ahead and write these down, and again, leave some space in your notebook to write the equations underneath. First is the decomposition of potassium bromide. The second is the decomposition of lead-4 nitride. So write them down, pause the video if you need to, and then let's write some equations. You ready? All right, so the first one was potassium bromide decomposing. Well, we have to first write our formula for potassium bromide. K is +1, bromide is Br-. It's an ionic compound, so that's going to be a solid, and it's going to just decompose. We're not adding anything to it because decomposition reaction is just one thing on the left here, and it breaks down. The 2 elements that make this up are potassium and bromine. Well, potassium is just K, it's a metal, it'll be solid. Bromine is one of the 7 diatomics. Bromine always exists as Br2, and if you look at your periodic table, you'll see that Br2 is a liquid. So for the last example, we're going to show the decomposition of lead-4 nitride. I need to draw the formula for lead 4 nitride. So lead is +4, nitride is -3. So that would be Pb3N4. And that's an ionic compound, so again, it's going to be solid at room temperature. And it's decomposing, which means there's nothing added to it, it's just breaking down. It's going to decompose into its elements. Well, its elements are lead, Pb, which is a metal, and that's solid, and nitrogen. And again, nitrogen is one of the diatomics. It's N2 gas, nitrogen gas. Okay? Now I need to balance this. I need 4 nitrogens, so I need to put a 2 there to get my 4 nitrogens. And I need 3 lead, so I need to put a 3 there. 3 lead. So that's really all there is to synthesis and decomposition reactions. It's a question of being able to write your formulas. Again, you have to practice writing formulas. But if you follow the rules, predicting the products of these reactions is not all that difficult. Good luck.